Okay, this is May 2014, paper 1, time zone 1, and we've got quite a lengthy 8-mark question with some trigonometric identities. So, first of all, we've got to use this equals this. This is a trig identity on the formula sheet to prove this. So the starting point for this is that I need to make theta equal to 1 over root x, and if we can just identify that theta is a half x, actually everything else now becomes relatively easy in the question. It's just now a matter of number work and a bit of algebra. So if theta equals 1 over root x, we're going to take this identity and it now becomes cos 2 thetas are going to give me x. And we put it into here and we get 2 cos theta is a half of x, and I want to square that, which is the same as this one here, and then take away 1. Now try to isolate cosine half theta, so I need to add 1 to both sides, so cosine a half x is equal to cosine x, add 1, divide both sides by 2, and then this is squared, so I'm now going to square root both sides, and I end up with what I've got up here. Just about. Okay, now I'm going to do a similar thing for this, so I need to look on the formula sheet and I find that I've got, this is A by the way, I need to find that the formula sheet says that cosine 2 theta can also be written as 1 minus 2 sine squared theta, like that. So again, what I'm going to do is I'm going to use this here to put it into here. So I've got cosine x is equal to 1 minus 2 sine half x squared. Now I'm going to isolate this again. So I'm going to have 2 sine half x squared, so all of this squared equals 1 minus cos x. Now I'm going to divide both sides by 2, so I just do it up here because I want to keep it on the same page. So I have sine a half x is equal to 1 minus cos x, divide by 2 and then square root. So if I divide by 2 and then square root, I end up with this number here. Okay, so that's A and B done. Now when I go on to do C, if I look at this, I'm obviously going to replace this with some form of this. So what I'm going to do here is I'm going to call this would be cos x, but times root 2 over 2. So I'm just going to do this on this page and then we'll do the integration itself on the other page. But just so you can see on this page, this value here is the equivalent of cosine half of x, but I need to times it by root 2. And this one is the equivalent of 1 minus cos x is this one here, which is sine half x, but I need to times it by root 2. So I'm going to do this one, add this one, I can take the root 2 outside the integral sign, so I'm going to end up with root 2 coming out. My limits stay the same, which is pi over 2 and 0, and I've got cosine a half x plus sine a half x dx. When I integrate that, this is almost the easy part. This is going to give me a half. Sorry, I beg your pardon. This is going to come outside and be divided by a half, so this is actually going to give you 2. And this one's going to give you sine half x. So this one integrates to 2, so it was the easy part. 2 sine half x. And similarly, this one is going to give me minus 2 cos a half x. Remember, it's a non-calculator paper, so I need to know, this is 0, my limits. Pi over 2 is going to go in, and 0 is going to go in. So when pi over 2 goes into here, it's going to give me root 2 times pi over 4, and that's going to give me 2 root 2's divided by 2 minus pi goes into here, gives me pi over 4 again, so it's minus 2 root 2 over 2. So that's the first bit, and I now want to take away the 0 going in. So the 0 goes into here to give me 0. Cosine 0 gives me 0, so I've got 0 here, minus cosine 0 gives me 1, so this is going to be minus 2 from the second bracket. So this is cancelled out, and plus 2 here, so it gives me the final answer of 2 root 2. This cancels out. Minus minus makes it 2, times it by this, root 2.